In the sandbox today, we're going to be talking about commercial databases, these legacy databases, versus the new innovations of the modern database. So get your questions ready. Let's start digging in. And director, roll the intro. Welcome to the Innovation Sandbox. My name is Mike Gonzales. I'm the Chief Data Scientist for Prolifics, a visiting professor at the University of Texas. I've written a few books on database topics, and I've been in the IT space like way too many years. I've got like 40 years out in this space. But this morning, I am your host, and my guest today is Tom Rieger. He is the Senior Solutions Engineer for EDB. Welcome, Tom. Why don't you give our attendees a brief intro?
Absolutely. So again, my name is Tom Rieger, and not unlike Mike, I've been in the IT space my entire 33 years of being an adult. I started when I was 12, if you're doing the math. Spent my entire career doing things in the relational world. So I did cut my teeth purely on open systems and relational databases when they were new, back when the cod paper was still fresh and the ink was still running on it. And as we progress into 2021 and beyond, it is amazing watching all of the things that are happening to make us appreciate and need databases more, that are better, that do things better for us, but still having a lot of the fundamentals in place. So I'm really excited to be here, Mike.
It's great to have you, Tom. So, let's. I want to start with the idea of these commercial databases. So these legacy systems, and I'm going to pick on Oracle or Teradata. They're easy to pick on. And when clients have a heavy investment in these type of legacy systems, they often experience kind of like the perennial issues of these legacy environments, where the licensing becomes really overly complex. You often have you're buying features that you don't really need or even want. You have this ever increasing pricing model that, just to continue to acquire it as well as to maintain it just seems to become more and more problematic. A publication, Tor Data Science, they recently published an industry trend on these commercial databases where it's relatively flat anymore. They don't really see a big uptick in interest. So it's relatively flat. So from your perspective, Tom, what do you think? What is today's client looking for in a modern database platform?
That is a great question, because I talk to clients every day, and I think there's this phrase that has become quite heavily used called technology debt. And technology debt isn't that the technology isn't doing its job. It's just that we have this entire stack of things that are going end of life, end of service, end of something, and we have a fundamental moniker of cloud first in 2021. Well, if I have these things that are on-prem, that are kind of getting old, they're getting a little dusty, or as I sometimes like to describe it, you bought Oracle back when this was how it was delivered, and now we're living with this as our new, kind of physical paradigm. And, as we sit here in 2021, we're looking for innovation. We're looking for terms and conditions that unleash us and let us use the technology the way we want. And we're also, as technologists, always trying to drive down the cost of our technology stack. And databases are that last frontier of commercially licensed software driving how you operate your business. And I see this area of open source finally finding its way into the database world, just like it has in operating systems and app servers. And, there's a list, right? Whether you're a Linux person doing JSON, using R, all those things are open source. And now finally the database itself is moving that direction.
You bring up the point about open source. So Postgres, which has a huge following, right? And it's not new. I mean, they're 30 years in the space. So it's been evolving for quite some time, but it does have some competitors, right? So for instance, like MySQL, a big competitor. Of course, MySQL is now acquired by Oracle, so they're owned by Oracle, right? And I see a lot of bloggers lamenting that the development of MicroSQL has really slowed way down. I suppose that's probably more of a strategy by Oracle as a whole, right? But one of the things that I've seen with Microsoft SQL as being promoted as a big advantage has been performance. But they've done that at the expense of compliance. So they don't really do SQL compliance like we've all come to expect SQL compliance, right? For security and just multi-currency. Can you give me a sense of where these competitors are with Postgres?
Yeah, I mean, so first of all, you mentioned a couple of interesting examples. If you are looking to commit into MySQL, you have to sign an Oracle contract. Does that truly define open source in the truest essence of open source?
That's right.
You have to sign a contract that basically states that you're giving IP to Oracle to apply things into MySQL. Well, so there's I'll call it posers. There's a lot of posers out there right now when it comes to this idea of open source. So if you truly want to be something with open source, you need to have an independent open community driving innovation, driving bug fixes, driving things. And you need to have an environment that also helps clients get where they want to go. What do I mean by that? Cloud independence. And I can tell you in cloud independence, that also means you need to not think that Windows is your operating system for your server. You need to be able to spell Linux. So, and trying to run things like SQL Server on Linux is trying to put a Ford transmission in a GM car for those of you in the United States. You're just looking for trouble. So you need to have that platform, truly platform independence behind it all. And you're right, Postgres has been around since Dr. Michael Stonebreaker was UCal Berkeley back in the 90s. Postgres was his next iteration after Ingress, for those of you who like a little history or lived it like Mike and I have. And it really was meant to be this extensible, relationally driven technology that was open source, actually before open source was open source. I mean, Mike started giving it away in the mid-90s. Open source didn't exist till 1998. So it was the original open source technology as a whole. Yeah. Well, let's fast forward to 2021 as we're sitting here in September, and version 14 is coming out in 2 weeks. It is an ever-evolving stack that's doing a superset of what you just described, Mike, because you need to be able to do, I'll call it all of those production-ready tier 1 requirements in the data set. And Postgres has been kind of in that third and fourth tier, just like the cloud has. You know, there's a natural evolution to all technology stacks. As we move from the mainframe to open systems, we kind of slowly moved into tier 1 platforms. As these open systems move into cloud, you see this evolution. And the same thing's on the database side, because everyone wants to make sure the data is right. Because if your data is wrong, you can't run your business. Planes don't take off, manufacturing stops. So Postgres as an open source technology has now proven itself. It's over 20 years old, but it's also still has a great amount of innovation behind it.
Well, so I want to take 2 points. One is that the compliance, right? So Postgres addresses something like 160-ish of the 179-ish features that are required for ISO or ANSI standards, which is absolutely phenomenal, right? So it's pure open source. It's literally an open source technology, but it's also one of the most compliant databases out there, which gives you all of the security, the data integrity, the multi-concurrent capability. Just all of those features just really help. That whole data integrity is really supported by that compliance. So it truly is a enterprise database type of platform. There was from a different standpoint, though. There was an idea from the research that is being conducted, where if with most databases now in enterprise type of scales, you're really looking at a distributed type of environment. And unfortunately, even commercial databases have a hard time doing that well. Distributed SQL is not a trivial thing. So beyond just the compliance, one of the things that is recommended out there by a couple of different research firms for the application of Postgres is its ability to handle millions of transactions globally using distributed SQL. And to me, distributed SQL and a modern cloud architecture go hand in hand. Can you kind of expand on that?
Oh, absolutely. Because you see all of these moments, especially as we've moved into the 21st century around data privacy and data residency. And so the cloud offers this ability to turn things on and do things quickly, but we also have to understand that different countries have different localization requirements. And so that means you need to find that right way to physically distribute things and logically distribute things. And one of the things that we here at EDB bring to the table is that ability to do things like very high-end, multi-master, multi-region replication that otherwise is not really available. It's not really available out there, especially in a platform of your choosing. Now, if you wanted to do this and wheel in those Oracle Exadata boxes like it's 1999 and do it in your own data center, go to town. But you're going to write a check with 2 commas in it, and you're probably still going to get the software delivered on one of those. So let's appreciate that as we're trying to move from this world of CapEx to OpEx. Now, I was raised by a CPA for a mother, and she taught me a long time ago, nothing happens until the accountant says so, which is, I think, was her way to tell me you don't get to do that till I say so. But if we think about IT professionals, those of us watching the video, all of these things mean nothing if we can't come up with the right ROI. But at the same time, to your point, you need to cover off on all of those governance, risk, and compliance requirements at the data layer. At the moment you hit commit work and put that on, in fact, I have a Raspberry Pi here. As you commit it to the storage on your server, CPA, the accountants have to placate those requirements because there is a moment where saving money hits a wall when you have to be compliant. And within Postgres, and again, the innovations around Postgres isn't just about the Postgres as an existing database. It's all the things around it, including things like governance, risk, compliance, and that local residency. And that's where, especially in the cloud, how do you then move this into a cloud, or how do you take advantage of that? One of the questions I saw come up was, how do you know when you have that moment where you need to do this? And it usually comes down to three fundamental things. One, are you done paying for extended support or having unsupported stuff? That's the technology debt conversation. 2, did you just get audited like it's 1999? Now, mind you, I sit in Minnesota, so I have to quote a Prince song, so I apologize, like it's 1999. Or 3, is there a top-down edict that says we're moving to the cloud? Well, guess what? If you're moving to the cloud, SQL Server really only works in Azure on Windows. Oracle only really works in the Oracle cloud. They don't like you to run it anywhere else because of those terms and conditions. If you're really going to go do cloud, you're going to look at Postgres. There's no ifs, ands, or buts. And then also that journey. How do you take that journey as you're trying to unwind the technical debt? It's almost like the Hoarder show on Netflix. You go into somebody's house and you see just this stuff. That's what it feels like in existing IT systems when it comes to what they pay for and what they get. You're trying to get to this better future world with unicorns and rainbows and cloud and OpEx, and you pay for what you use. To do that, Postgres is your database of choice.
I completely agree, right? So true to its heritage. Postgres can run on Azure, it can run on AWS, on Cloud Pak for Data, on Google. And frankly, all of those platforms, all of those cloud architectures actually integrate Postgres. And to a certain extent, many of them just immediately have it available as an option, right? So even Microsoft might promote their own SQL environment, but oh my God, I can see all kinds of variations of Postgres immediately available as well. So it's not mutually exclusive, right? Oftentimes Postgres starts filling a very specific role. Before you, well, maybe before I go to the next topic, you were going to say something, Tom?
I was going to say that I think what's driving a lot of this too is, and I mentioned this earlier around so many other aspects of the world in technology is already open source, and it's being driven by open source. And that means that those other tools you use out there are also being built on other open source components. So that generally means that what you're using now was built with Postgres in mind. What the kids are learning in school today is with open source in mind and cloud in mind. So if you're thinking about also that next generation of application you're going to create, that next generation of employees you're going to have create these technologies, and that next generation of end users using these technologies, it really has where we're hitting that tailwind of open source now that you can use an entire stack that gives you the greatest amount of innovation, the greatest amount of the lowest cost, and also the easiest terms and conditions to legally do with what you want with it. It's that trifecta that's really behind all of this activity. Because 20 years ago, the development tools and the operating environments, they were all commercial software. I mean, does anybody remember how much your maintenance bill was for, let's say, Solaris or AIX or Unix, or how much your bill was for Oracle or Sybase back in the day? And you add all that up, they were all very best in breed proprietary things, really expensive. And the challenge was, once you had to change out one thing, it turned into a problem. Today, the entire DevOps stack and what it takes to do regression testing to move to something else has become almost academically simple.
Yeah. One of the things that you had mentioned was the whole innovation of a modern platform like Postgres. And Postgres is really no longer, or it hasn't been, a relational database per se, right? Like structured data. It is really an object. If it's relational, it's an object-oriented relational database, which means that it's multi-model. So, we're used to the traditional, or some folks, certainly you and I grew up in that era where it was heavy structured programming, structured modeling. It was heavy OLTP. And Postgres does all of that, but that's really kind of a narrow focus anymore. The models now are becoming, for instance, completely unstructured type of data, a lot of big objects, and Postgres allows for a lot of different handling of large free-form text. But in addition to that, one thing that I thought was a strong caveat for Postgres was its ability for geospatial modeling. I mean, just literally being able to do overlap or intersects or running unions against spatial objects, right? So understanding these polygons and which is spatial analysis is everywhere. Frankly, all of the students in my class and the generations that are up and coming, these guys are all using Snapchat or whatever. They're trying to figure out where their friends are and whatever restaurants nearby. It is entirely spatial analysis. So maybe you can speak to a little bit about that whole spatial component and other innovations in Postgres.
And that's a great example where I work with clients, I would say every week, where they are talking about the extensibility of Postgres. Because once they kind of move a workload into Postgres, after you move something into Postgres or you build something into Postgres, you now figure out, how do I take better advantage of the technology? And one of those is exactly what you said. And it builds off of the backs of what Mike Stonebreaker wanted over 20 years ago for Postgres, which is, this is much more than just rows and columns of traditional data. This is, and if you look at too, the single largest used geospatial technology in the world is PostGIS inside Postgres. That is the largest used geospatial tool in the world. Because to your point,
I didn't know that.
The data points we talk about today, if we fundamentally think about life, is measured based on when, where, and what.
Yeah.
When, time component. Where, geospatial. What, It's, it could be any kind of data you're talking about. It could be your products. It could be tech support calls coming in. You need to do voice to text conversion. You have all this text data. And also you need to do that in a way in which it's scalable, because there is this perception that open source is only good for dozens of people. I'm working with clients who are having connectivity of 35,000 concurrent users coming into Postgres. Yeah. So the ability to think above and beyond doing unstructured things for the masses, whether it's your employees, the world, or both, is a reality. Because, for instance, how often when you go in to look for a hotel to stay at, are you looking for something around a certain area? Or when you're doing crime analysis, the police department or the detectives are doing things in relation to a geographic center, or they're trying to find hotspots. I would challenge that the single biggest use of data visualization today and tomorrow become much more visual in the areas of things like the wheres and the whens. And that requires your ability to analyze the data at its roots. And that,
as gentlemen who have grown up through all of these different eras in IT, I used to laugh at the businesses. So we're talking about private sector. Yep. So private sector usually looked at government with a bit of disdain in terms of technology. We're the private sector. We do all the latest and greatest and blah, blah, blah. But I got to tell you, back decades ago, if you wanted good spatial analysis, you could only find it in a city government, right? The sanitation collection people knew more about spatially everything than, many of the leading commercial privately held companies. They oftentimes had nothing to do with spatial. I was working on a strategy for a wholly owned subsidiary of a major auto manufacturer. And this subsidiary was all about, you touch a button and somebody comes on. It's kind of like an old version of Siri for your car. And if anything was spatial, that was, right? So wherever you're driving, I know where you are, blah, blah, blah. If you need a gas station, you take the next exit, you go under the overpass, blah, blah, blah. If any business was spatial based, it's that business. And when they were considering analytics, they never had spatial objects within their data warehouse. They never even thought about that. It was something else that was done by some other department. And that's just insane. And I think the usage of spatial analysis today is what's driving private sector companies to actually start trying to embrace it more aggressively. But Postgres has been doing this for decades.
Correct. Well, and I worked at Informix back in the 90s, for those you remember Informix. And
Informix is near and dear to my heart.
We had extensibility in the database, and we were doing a lot of these things back in the day. But it really, in some cases, takes a couple of decades for things to take off. And one of those big ones is this extensibility. By the way, I think one of the reasons why it has nothing to do with software. It has everything to do with Moore's Law. For those of you who don't know Moore's Law, that's Gordon Moore, one of the founders of Intel back in the 60s, who stated how every basically 2 years, computing technology will double in the speed, period. Well, what that really means is we fast forward to 2021, now you can have more power in your iPhone than they had in the Apollo space capsule. Now you have the cost benefit of this thing called the cloud that's makes compute that much easier for you to consume, or storage. Over my shoulder here, a couple examples of some old hard drives that, if I think about how big and old and slow they are, and they're only 10 years old, it's embarrassing compared to, this memory stick, which is 32 gigs in size. And I got it at a Micro Center for $6. So this area of Moore's Law giving us compute, RAM, and storage. And also, I don't know about your home internet. My home internet has now 1.2 gigabit download speeds, and I pay $75 for it. So the economics of Moore's Law giving us this as a foundation, then we throw all of this open source on top of it, driven by Postgres as your system of record, has really opened up this area where now, think about it, 20 years ago, we would get data refreshes once a month from something, and we'd have 29 days to look at it. Today, we have so much data coming at us real time. We need to be able to do more with it, but that means we need to have more flexible database management technologies to do that. And I think that's where this gets exciting.
And multi-model. I mean, we're no longer just stuck in the mud with structured data. For crying out loud, if you have problems with structured data, you've got bigger problems. You've got much bigger problems these days.
And let's use this as an example. We have structured data that really, if you want to analyze it, becomes unstructured. For instance, in your database for the last 30 years, you've had a field called zip code that tells you something. You know what? That zip code is really a latitude and longitude that you can do covariance analysis around. So even your structured data, you could do more with if you kind of got out of the box a little bit. But to get out of that box, you need to make it easy for you as technologists to use, you as your data scientist to use. But most importantly, if your line of business people and your non-technical people don't have a nice, pretty way to look at it visually, it's not going to work. And that's all available today.
Well, so Tom, we're going to have to kind of wrap things up. I think you and I could go on forever. There's a few questions. I'm going to have to read these. Just give me a second here. We're going to. There's a long list here. So you answered the one on the when is it time, or how do you know when it's time to switch? Well, technical debt is one way, but just taking advantage of that modern cloud architecture, right? Where you're paying by the drink, you have flexible charge models. I mean, there's just an enormous amount of flexibility. Scalability, I remember using Postgres for one solution. I threw 64 CPUs at it, threw Postgres on top of it, and I was able to, crunch through everything that I needed to crunch through quickly. And then 5 seconds after it was done, I dumped the 63 of those 64 nodes, and I was back to one CPU. So it worked. Just that scalability is fantastic. Those are all big signals that you need to really start thinking about a modern architecture. Open source, is Azure a good option? Azure is the leading cloud architecture, along with AWS, Cloud Pak for Data, Google. They're all good competitors out there. I won't say anything more about that. Why open source databases on a modern? What makes them stand out? There's a good question. Why open source on a cloud architecture?
There is technical reasons and there are business reasons. The technical reasons is if you look at when I talk about innovation, one of the big innovations around things like Postgres, and we actually have a lot of engineers inside our company doing this, is taking Postgres and making it optimized for that cloud. Secondarily, and we didn't even talk about this, there's this whole thing called containers. A container used to be a box we would ship things in. Now a container is a way for you to provision software in a very different, more streamlined way today. Commercial software is not container friendly. They were not designed for the cloud. Where Postgres, because it is open source, you can pivot it into doing things much, 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 much faster and much, 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 much better, because you're not a slave to a single R&D organization. You have a global organization out there driving that iteration and that evolution. So I would challenge that no matter what your cloud is, of choosing your container strategy. And also, I would bet that anybody watching this video, if I ask everyone what you think cloud means, I'll get all kinds of answers. So it really is that independence of having it fit into your strategy versus the limitations of it limiting your strategy.
Love it. One more question. Maria is asking the intense focus on data privacy, and that's just going to escalate, right? Data privacy, security, just a giant issue that we have to deal with today. Is Postgres up for that challenge?
Absolutely. So there are things built into Postgres from a physical privacy perspective, auditability perspective. I'm a big player, again, having a CPA for a mother, you appreciate the word audit at a very young age. But then there's also things, for instance, like within Postgres and within what we bring to Postgres here at EDB is your ability to do things like data redaction. So for instance, if I have Tom Rieger's birthday or credit card number in the database, and maybe you as the credit department can see it, but someone else on this call isn't allowed to, you can manage that redaction down to the granular level inside the database. So you can see the number and the other person just sees X's, right? So redaction at its fundamental essence. So you can do that at the physical layer in the database, but you can also logically do a lot of things around cybersecurity, right? And how you can make sure that things are properly encrypted in flight, encrypted at rest, and also make sure, and there's an aspect of this for us database people, there's one aspect of cybersecurity I appreciate, it's called Sql Injection Protection. Go read up on it and be like, hey, that's a good idea. Let me go try that on a website. But we bring that to Postgres so that it doesn't have a chance to get physically harmed by the bad element of the internet. So it is there.
And there's a nice overlap between, you had mentioned that a giant community behind Postgres, and that's really substantially better than one R&D department, just simply because it's more in tune with what's happening in the marketplace. It moves a lot quicker. It is more influenced by the requirements of today versus R&D budgets versus somebody's priority or their own bias. But the overlap with Postgres and the cloud architecture when it comes to privacy and security is substantial, right? Because one of the big advantages of going to a cloud in the first place is the fact that you do have that added security. Now, a lot of it comes just with being there, but then they have so many other layers that you can add onto it. And when you couple that cloud architecture plus the security that Postgres is providing, you really do have a relatively large landscape of options available to you.
Agreed.
All right, so Tom, I think we are at a time to start wrapping up. So first of all, I want to give a big thank you to you, Tom. You're going to receive one of our hotsy-totsy, really, modern Innovation Sandbox cups. Our director is showing it right now, so
I need the big.
It's going to be even better than that. I want you to run down to your mailbox and wait for it today. It ought to show up today. And for everybody else, it's been a pleasure. I hope you guys have found it to be informative. I would love to have you join us in our next Innovation Sandbox in October. Follow us on social media, Facebook, LinkedIn, all of the other stuff that's out there from our marketing folks. And please do come to our website, prolifics.com. Thank you, Tom, again. Thank you, folks, for attending, and happy innovation. Bye now.
Thanks, everybody.